All right, well, good morning, everyone, and welcome back to another exciting day in mathematics. Woo, woo. How's everybody doing? Good? Yes? All right, once again, warm-up number 67 is on your screen. Number one reads, use -2, 0, 2 to evaluate the functions f of x equals 2 to the x power and f of x equals 10 to the x power. Number two reads, graph f of x equals x, then transform given g of x equals f of parentheses x plus 4 close parentheses, all of that over -2, and then with a constant next to the fraction with -5. Number three reads, rewrite each expression. Part A is a to the -2 power. Part B, 150 to the 0 exponent. Part C, 1/4 to the -2 power. And number four reads, if x to the third times x to the fifth is the same as x to the 3 plus 5 as the exponent, which is x to the 8th, then rewrite 2 to the x plus 2. So take a step backwards and see what it would look like and simplify as far as you can. I'll give you some time for that. Copy and go. All right, so you should have been able to do all four of them by yourself. We've been practicing with these, specifically 3 and 4, because I want to make sure you are ready for what we are doing now with these functions that we are covering, and also what's coming with the next function that's coming up. So you'll finish that up on your own. Our agenda for today, copy this. We have warm-up number 67, which you just completed. We're still focusing on exponential functions. And your home plate for tonight's page 661, all only. And yes, they are from volume 2 of your books. And some of you are asking yourself, Mr. Cube, so what happened to volume 2? Well, they handed it out. You're like, what? I didn't get one when I went to get my book. That's because you probably went when they were out of volume 2. So let me repeat that again. At the beginning of the school year, I said, go get your books. There's only so many volume 2s. You're like, oh, I think I remember now, Mr. Q. So if you got there later, then you only got volume 1. Everything that we're doing from this point or from the previous lesson to the end of the year is on volume 2. And somebody like, so what do we do, Mr. Q? Well, if I recall, I gave you a login user and code for the online book. Is that correct? Oh, that's true, Mr. Q. I wrote it down. So I took copious notes. I just need to go to my notebook and look for it. Yes. So go to the first week of your notes, and it should be in there. It's you should have a username and password. Right? Am I right? Now, for the sake of, let's say some of you are Power Rangers and somehow something happened to the notes. That evil Martian or person in your Power Ranger world sent a laser and took away your notes. Okay, so from this point forward on Canvas, if you go to Canvas right now, do that right now. I included a new module titled Exponential Functions. And the first 2 things you're going to see in there is your home plate from last time, which was pages 643, 644. And also this page, 666, 661. They're both in there. Mr. Q, but I didn't do the home plate. Okay, so I'm going to give you guys till Monday to turn it in. How about that? Will that work? Yes? Thank you, Mr. Q. You're always thinking ahead of things. I'm telling you, I got this. Now, I was thinking that maybe you guys didn't even need it since you already have the electronic code and you went to the electronic book online. But for the sake of the Power Rangers in my class, asynchronous code, here you go. Your asynchronous code is M2TYN, N2TYN. And I think there was like 4 of you or 5 of you that said that something happened to your book, right? Some of you. So that's 5. That isn't that the power interest? Aren't there like 5 of them? Oh, there you go. Let's go. All right. So once again, your home play last time was page 643, 644, and tonight is 661. So all those pages I'm going to pick up on Monday. So that gives you an extra, let's say, what's today? Thursday, Friday, Saturday, Sunday, Monday, 5 days. Let's go. Okay. Yes, Mr. Q. All right, and just to get the jitters out of the way, like all day, students have been asking me in regards to the new schedule and such. So here goes. The new schedule is on your screen. You guys see it? So if you didn't pay attention during your advisory or you just woke up and came to my class, here it goes. We have a new schedule starting Monday. And it goes as follows. From this point forward, every Monday, we're going to have periods 1, 2, 3, 4, 5, and 6 in a row, starting at 8:30, 30 minutes each period. So you're like, Mr. Q, so we don't have advisory anymore? From this point forward, no more advisory. Tell your neighbor or your dog or your cat or your pillow, the one that you hug at night, like, oh, no advisory anymore. So periods 1, 2, 3, 4, 5, and 6, half an hour every Monday from this point forward. So that means that that's 4 Mondays, 5 Mondays. Okay. Then lunch, and then for teachers, they give us planning time, which that'll allow you guys from 12:30 to 3:25 in the afternoon to do asynchronous work, whatever it is you need to do. Okay. Let's go to Tuesday. Tuesday, Thursdays, kind of like today, is the same. We have periods 1, 2, and 3, then lunch, and then we have planning for the teachers to get ready. However, if you notice, it repeats in the afternoon, periods 1, 2, and 3. So this is what happened. They took away our advisory. You guys see that? No more advisory. Okay. They took away our tutoring or synchronous whatever after school. You guys see that? Yes. So here goes why it's repeating. For those of you that signed up to be face-to-face, so that means starting next week, you're going to be face-to-face in the afternoon from periods 1, 2, and 3. What does that mean about the morning, Mr. Q? That you don't have to attend the morning session. It's the same lesson that in the face-to-face interaction. You're like, oh, so it's either or? Yes, either or. So what if I go to Zoom in the morning, Mr. Q? Then you don't have to go in the afternoon. Does that make sense? Yes.
So
Okay.
is it like optional? Can we like alternate all the time?
It's optional. It's up to you. You either go to one or the other, but that day you need to attend the first period either by Zoom or face-to-face. If you don't attend either or, then you're absent. Okay? Now, I want you guys to notice that since they took away the advisory and they added all 3 periods in the afternoon, now our classes are going to be crunched to 45 minutes instead of an hour. And what do have you guys noticed with our lesson in Algebra 2 throughout the year? That we always usually finish at what? At the bell, because it's so packed with stuff. And that's not going to change even till the end of the year. So I need you guys, especially those of you that are always late, not mentioning any names, you need to be on time. Not like if you're running from the gym to my classroom. So be on time, please. If you are going to be in face-to-face, get there earlier. So like that, you can get there earlier to your class. And notice in the afternoon, they do give you a 5-minute pass period from period to period. So like that, in case you are face-to-face on campus, you can go to your next class. Okay? So make sure you stay, because guys, since we have a bunch to cover, so let's say you are in my 3rd period, starting Tuesday. we need to start at 10 a.m. So the warm-up is going to be starting at 10 a.m. So we'll probably cut it to like about 4 minutes. So if you're 5 minutes late, you already missed the warm-up, which is part of the lesson, guys. I don't know if you guys noticed, the practice on the warm-ups really, really strengthen the skills that we need for the lesson. Who noticed that? You guys notice that? Did I give you guys skills on the warm-up? Yes. So if you're being late, if you're not doing the warm-ups, guess what? Then you are very much struggling with some of the concepts that we're covering right now. Okay? Now, that's that. Now, let me just cover the last piece, is the calendar. Do you guys see that on the screen? Yes? All right, so today is the last day of April, which is the 29th. I mean, today and tomorrow is the last day, 30th. And by the way, it's going to be 104 degrees. Yes, bring it. Bring it. 104. Welcome to the valley. All right. However, after that, look how many weeks we have in May. 1, 2, 3, 4. And for us at the high school, not like at the middle school, they want us to turn in grades this week, the last week of May. You're like, what? So what does that mean, Mr. Q? That we only have 3 full weeks of instruction, that you need to stay on top of your work, because this last week of May, we turn in grades. All right. Hopefully I made that clear. All right. So with that said, let's move on. Our objective for today, I can graph exponential functions. I can graph exponential functions. So have we been doing that? Yes, Mr. Q. And thank you for those of you that reached out via email. I sent you the home plate page, yes. And some of you that got it from someone else. That's good problem solving, real world problem solving. Let's go. All right. So exponential functions. Give me a definition, example, non-example, and a hashtag. All right, and you can do that on your own. You should have all the components by now. All right, set that aside. You can finish that a little bit later. Look up to the screen. So from there, I went ahead and revisited our general form or transformation rule. And even though we've been graphing, guys, I've been referring back to the transformation rule because I want you to see how everything is related and how you can apply the transformation with the graph. So I said from there, this is the new rule, and the new rule applied to the new function, which is exponential functions. And we saw that the parameter pretty much matched the new one. From there, we said, let's get to graphing. And I gave you a parent function of f of x equals 2 to the x power. And then I asked, does it have a constant? No, it doesn't have a constant. So that means that our asymptote was at 0. And we graphed it. From there, I gave you guys this one, g of x equals 2 to the x minus 1 power. And I asked you, what did it do to the original function now that it has a transformation? Well, this one right here moves the entire function, f of x, 1 step to the right. From there, I gave you another function, g of x equals 2 to the x minus 1 power in parentheses, and then with a constant of -5. And I asked you, what does this do to the original function? It moves it 1 to the right and 5 steps down. And then we saw, here it is, this is what it looks like, how we ended it. Does that look familiar? Yes. Once again, here's our f of x, then our g of x with exponent x minus 1. That means it moved the whole function 1 step to the right. And then this one with exponent x minus 1 and the constant of -5 outside of the parentheses, move our original function 1 step to the right and 5 steps down. 1 to the right, 5 steps down, and here it is. We good? Yes? Yes, Mr. Q? All right. So from there, I said, for your asynchronous work, I want you guys to graph this one, which I'm pretty sure you guys did, yes? However, for the sake of those that were absent, Let's do this one again. So write this down on your paper, please. It says, example 2, graph g of x equals 1/3 to the x power. G of x equals 1/3 to the x power. G of x equals 1/3 to the x power. All right, set up your coordinate plane. In the meantime, I'm going to rewrite this here next to the table so I can do some computation and set up our range. Let's see. Right there. Okay, so I'm going to write G of equals parentheses 1/3 and then a blank for the exponent. So I'm going to use blue. So I'm going to substitute -2, -2, -2. So, question. We have 1/3, which is a fraction, to a -2 exponent. What do we do to that? What do you think, Mia? One fraction to the negative exponent.
Reciprocal?
Reciprocal, that is correct. 3 over 1. And then we distribute the exponent as a positive. As a positive, yes. So that is 9 over 1, which is 9. You're like, oh, I see, Mr. Q, what you did. You gave us that practice ahead of time. Of course. That's why we've been practicing diligently, those warm-ups, right? Yes, Mr. Q. All right, good. Next value, -1, -1, -1. All right, what do I do to that one, Jaziel?
You do the reciprocal.
3 over 1 and distribute the exponent as a positive. 1 and 1, so this is 3. Move this up. All right, next, we got G of 1/3. Let me do that for all of them so I can go a little bit faster. 1/3. G of 1/3. G of 1/3. All right, my next value is 0. All right, so what is 1/3 to the 0 power, Anthony?
1.
1, that is correct. Let's go. Next value, 1. 1/3 to the first power. What do you think, Octavio? Help them out, Angie.
1/3.
1/3. Yeah, because any number to the first exponent is the number itself. Okay. Let's try 2 now. Distribute the exponent. So this is 1 to the second, 3 to the second. So this is 1 over 9, which is 1/9. Last but not least, to the third power. Distribute the exponent. So you should have gotten 1 over 27. Check your work from last night. See if that's what you have.
Mr. Q, I have a question on that.
Yes.
So if we're doing it on home play or like on a test where we're supposed to show our work, do we have to do that for every problem? Because if we know that like -2, like if we know that you just put a 1 over it, can we just do half of them or do we have to do all of them?
You mean, do you need to show all this?
Yeah, like if we already know that -2 is 9, so we know that 2 is going to be 1 over 9, do we still have to show that 2 is 1 over 9?
Hmm, good question. I would say, I mean, if you show me at least 2 or 3 of the work, that's fine.
Thank you.
And the reason that I want to see work, usually also when we do the pop art case, is that some people, not you guys are fine students, but there's some people that don't do any work, believe it or not. Can you believe that? No. Oh, I've heard. All right. So to graph this, what was the process to graph this? Well, the first thing we need to identify are horizontal asymptote, which is y equal to. So what would be our horizontal asymptote? Hayden. What is it? I'm sorry?
0?
0. That is correct. Oh, thank you. So then let's get our horizontal asymptote shown right there. And why is it 0, guys? Because it has no constant next to our base. No constant. That's why it's 0. Okay, let's graph our function. -2, 9, -2, 9, -1, 3, -1, 3, 0 and 1, 0 and 1. 1 and 1/3. This is where it gets interesting because we need to get really close to the asymptote. So I'll zoom in. So we got 1 1/3, 2 1/9, and 3 1/27. Okay, 1 1/3. 1 1/3 of the way is about right there. 1/3, 2/3, 3/3. 2 1/9, very close to the asymptote. 3 1/27, very, 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 very close to the asymptote. And so on and so forth. It keeps getting close and close. So I'll just put my arrow at that point right there and then graph my function all the way. So let me zoom out. All right. All right. So there it is. So by looking at it and reading it from left to right, everybody with me so far? There's the graph. We're looking at that graph from left to right. All right. And I'm talking about the graph, not the asymptote. I'm talking about the graph. And you're admiring it. And all of a sudden, in walks your little cousin, your little brother or sister. I don't know if you guys have one of these, but when I was growing up, I had one of those that they always wanted. Like if I was eating ice cream, they wanted ice cream. If I was wanted to go play with my friends, oh, take your little brother. Oh my goodness. Uh-huh. So let's say they walk in right now. And they come and they're little and they ask, what is that? And you're gonna say, check this out, fill in the blank. I'm gonna give you what to say. Oh, well, this is a graph. And the way we read it is starting from left to right, left to right. So follow along with me, you tell them. So if we start from left to right, I start here, fill in the blank. What would you tell them happens to that graph?
Decreases.
Decreases, very good. Decreases. And that's for kids that are in elementary, right? But if you have like a 2 or 3-year-old, they don't understand what decreases mean. It means what? What would you tell them? That it's going what?
Va para abajo.
Pa abajo, yes, or down, yes. That it's going down. Okay. Good observation. And then you're like, yeah, because yesterday we did these. And then you switch back to the previous day. And then they're like, oh, so, and then you tell them, yeah, because look, if you follow this one from left to right, what would you tell them happens to these?
Increases.
They increase, that is correct. Or that they're going up. These are going up. And today we said that they are decreasing or going down. Okay, so now let's say they already left the room. Now this is for you guys. Pay attention, look up to the screen. If this is true, this is decreasing. And the ones from the previous session, they're increasing. I want you to look at the function itself. Look up, please. Here's my function today. Here are my functions from yesterday. Function today. Functions from yesterday. So in your brain, what's happening from one to the other, from last time to this time? And how would you summarize that thought? What's happening from last time to today? And how would you summarize that? Let's see. What do you think, Esmeralda?
The graphs are flipped.
The graphs are flipped. Okay, that's a good observation. What else? What do you think, Addie?
Instead of using whole numbers, we're using fractions, which flips the graph.
Okay, so fractions flip the graph or make it decrease. And whole numbers, you said, is that correct? Whole numbers as a base, they increase. So a base, which is a fraction, it decreases. And a base that's a whole number increases. It's a very good observation. Now, yesterday, I asked you guys to copy this table. And according to our general rule, I wanted you to make observations for each parameter. And you needed to use the Desmos app or the site. And there was the code. I gave you guys another code that I left you guys off, but this is the code in case you weren't here. And you are able to move the levers and find out what it does, okay? Well, let's summarize what we found out. Here we go. Let's make sure that we got it. So I want you to write this down. G of x equals a times b to the x minus h power, close parentheses, plus k. Let's summarize this. So very good observations from all of you. And we said that B also stands for base. Is that correct? Yes. Okay. So base, today we saw the difference between what we did yesterday, which were what? Whole number, to what we did today, which was a fraction or decimal, right? And what did we say? If it's a whole number, if we read it from left to right, it looks like this. If it's a fraction going from left to right, it looks like this. And some of you said increase, decrease. All right. Well, in mathematics, these functions, because of that observation that you did, are called as follows. This is growth. This is a growth exponential function. And this is a decay exponential function. Growth and decay. So whenever you hear people talking about, oh yes, did you guys cover growth and decay functions? Yes, we did. They're exponential functions where the base is whole when it grows and fraction when it decays. And the rest of the parameters we should know by now, yes? Yes, Mr. Q? So look at K. What did we say K does to the entire function? Well, if it's a constant, and it's a positive, it goes up. But if it's a negative, the whole function goes down. Also, I'm gonna box this in red. K, I'm gonna box it in red. and it plays a second function. What was the second function that it played? It's our horizontal asymptote.
Asymptote.
Asymptote, yes. All right, with that same mind frame, once again, we have h here. What does h do that's next to the exponent of x? Well, it moves it to the right if it's positive, or it moves it to the left if it's negative. So that means if we substitute a negative number here into the exponent, since the form already has a negative, negative times a negative becomes a positive right there. And last but not least, what did we say a does? Well, if it's a whole number, it stretches. And if it's a fraction or a decimal, it compresses vertically. Does that make sense? Yes? Yes, Mr. Q? All right. So just to make sure that we are clear, we started off, and this is just a simple introduction to graphing exponential functions. We covered this on the previous session, and you guys observed that all three of them, yes, they increase, but then from the parent function to this one, move it to the one to the right. From the parent function to this one, moves it one to the right and 5 down, and that our asymptotes is a constant of each of these. And then from there, we also covered today this kind, that if we have a fraction, then it decreases or it goes down. Okay. So from 1 to 5, how comfortable do you guys feel with this intro to graphing exponential functions? They sent you a poll on your screen from 1 to 5. Yeah, 5 4s, 5 4s, 5 4s. Yeah, and you're saying, you know what, Mr. Q, this seems very simple. And you know why? Because we've been practicing transformations all year. It should be able to transfer now, yes? Transfer, get it? Transformations. See what I did there, Beth?
Asymptote.
Yes, asymptote. All right. So, did we graph exponential functions? Yes. So, to recap in regards to the home plate, the home plate for tonight is page 661. Your asynchronous code, M2TYN. And your home plate from last time, 643, 644. Where are you going to find all those? Well, Ms. Q, I'm going to find them at in the canvas in the module. Okay. All right, guys, that's our session for today. Once again, remember we have face-to-face this afternoon. Make sure you are there on time. And now that you have the new schedule for next week, once again, start working on getting up early, because or else you're going to miss a lot of stuff at the beginning of the day. All right. Have a good one, guys. Enjoy your home play, and I'll see you guys next week. Peace.